Hi, let's talk about the path you can take from a legacy codebase to DDD. Let's start by answering the question, what is legacy code? And there are several definitions. The last one, called no test, is by Michael Feathers, who wrote the book about how to deal with legacy code. But overall, a typical legacy codebase is either very coupled to framework, it's usually very monolithic in terms not that it's not microservices, but also that there are no layers at all or no modules. There's usually no or very vague architecture. But it's enough that when a codebase has no tests, we can also call it a legacy codebase. So what is DDD? This is like the target of this presentation. There are two parts of DDD. There's the strategic part and the tactical part. And I think the strategic part is vastly more important, while the tactical is useful, but only in certain contexts. And many people focus on the tactical, or it's called DDD-lite sometimes, more, which might be a waste of time sometimes. So the tactical DDD, so the DDD-lite, it consists of several patterns. I listed some of them. I made the aggregate in green because I think that's the most useful concept here. So we can think in aggregates, which we'll talk about it later. And DDD-lite flow looks like this. We start with an application service, which calls one or more domain services. And the application service is like the top layer. It's like the API for our application. But let's not confuse it with the API of a Rails application. It's the API of the layer below the Rails application. And so then we have domain services. They can take a repository as an input. And then you load aggregates from the repository, do something with the aggregate. And the aggregate is like it's like some objects together, but usually there is a root object. So we can think like the user object with address, or the project with project members and the customer maybe and some tasks. So that's the whole aggregate. And then you want to do something cool, like maybe you want to add a new task to the project or a new member to the project, to the team. So this changes the state of the aggregate, and then you save it to the repository. And the details how it's saved is a detail, but usually you have some detection like what has changed and what do we need to actually persist to a database. What is the kind of database used here? It doesn't really matter. So to put it differently, if you put a DDD into a Rails application, you have the URL at the top, then you have the Rails action, and then the Rails action calls the application service. Nothing more than that usually. And the application service calls the domain services, then you call the repo, then you can call active record. And active record is just an example here because it's useful to manipulate the data, and then you call database. So you see more layers here than in a typical Rails application where you would have just the controller and the model. Also you have the view, but in this case you also have the view. So at the end you need to render something, but it's not so explicitly listed here. So one thing to note is that one application service can call multiple domain services. And in the DDD world you can see many different definitions on what is a domain service. I focus on this kind of situation. So in Rails you will probably have something like the customers/update, which will be responsible for updating the data from the customer. But in practice, what usually happens is that you have several different sub-actions, I would call it. Here I call it domain services. So maybe the customer moved to a new address, and that's why you are updating the customer. Maybe they changed the email. That has some interesting consequences. Maybe they have a new contact person, so you introduce a new contact person. Please note that we are now using a more domain verbs, domain words here. And in a typical Rails application, what I learned is that usually the update and create actions are the ones that hide many domain services. In one of our projects, one request, so one Rails action, was actually responsible for 15 domain services under the hood. So this is a nice discovery usually when you can split one of your Rails actions into several services. Okay, so that was about DDD-lite. Now strategic DDD, the more interesting one. So strategic DDD is not about the layers so much, it's about what kind of boxes you have in your application, how many applications do you have, what are the modules here. So they call it bounded context to say that this is like one context. I often call it a module. And a context map is like a drawing which shows all of the context. So here is a mandatory thing from Martin Fowler, and it shows on the left side you see the sales context, on the right side you see the support context. You can see that in both of these words there is a concept of customer and a concept of product. They could be called differently. In this case they are called the same, but they represent the same concept in the whole word. However, they use different models, those are different like domains here. So in the sales context, it's more about opportunity, pipeline, salesperson, while the support context is more about tickets, defects, submitting defect, or explaining the product version. So you can also imagine that a bounded context is like a department in a company. Very often they fit one-to-one. Many programmers work at software houses or dev shops or whatever else it's called. So I can show you an example of what could be a software that automates the work of a software house. It's a pure imagination. I didn't see such software. So you have the world of human resources, HR. You have the world of project management, where developers are assigned to different projects or to multiple different projects. You have the world of finances, where you calculate how much the clients pay to the company. You have the problem of communication within the team and outside the team, and you have the problem of invoicing. So once you know how much to charge the customer, you need to send them an invoice. Some of those contexts are more interesting from the company perspective, while some are less interesting. For example, when we send an invoice, it's not our business idea to send the best invoices in the world. So invoicing is a problem that is probably best to outsource. So the bounded context of invoicing will be very small and will be just responsible for using the external software as a service, which helps us build invoices. And that's all. While the project management context, where we assign developers to projects and we look at skills of the people and so on and the experience, this is an interesting one because there is some logic there. We probably want to keep track of the whole history. So I would consider implementing the project management using the many layers from DDD-lite. While invoicing, I would probably just use some straight calls to the SaaS. The same with human resources. Most likely we just have some, list of people in the company. So maybe it's a CRUD, maybe it's almost like the DDD-lite because you want to keep the history, but it probably doesn't have that much logic. Finances, this is important. I don't want to make any mistake. I want to be very testable. I want to be very right. I want to keep track of everything that happened in the finances world. So DDD-lite sounds like a good implementation here. And optionally, we can treat all of those modules as microservices. And if we do it right, if we split the modules right, we can make them partially available. So even if we don't, let's say that the microservice is responsible for human resources, so the one that keeps the information who is actually working at the company, let's say this microservice is down. So if it's down, we still want the other services to work. And we can do it by making some basic data duplication. Excuse me. And all of those modules will use different persistence conceptually. Physically, it can be the same database, but the important rule is that one module doesn't look at other module database tables. They only talk through the public API, which usually is the application services. So when a new developer joins the company, and so it exists in the human resources, we publish an event that a new developer started working at the company. The contract was signed, so they started working. So the project management context can be called with this idea that we are introducing a new developer now, and they persist the developer data as well. So we have those duplication, the developer information. Some information is the human resources, while some information is in project management, which means that when human resources is down, we are not querying the data back. So we are not querying from project management to human resources to retrieve the list of available developers because we already have it. But what it also means is that when we have a developer leaving the company, they are for any reason they quit the company, we also notify other places that this happens, and those other places need to persist this information that this developer is no longer available for assigning to projects, for example. Probably in most of those contexts, we will see the concept of developer, the concept of a project, or the concept of a client. In some places, you will see more more focus on developer, while in other places, the more focus on project. If we did a typical Rails monolith application, it would be all together, and you would see the developer class being responsible for many different things, like also for the finances and for the communication and project management, human resources. While here, the goal is to split it, to separate those concerns. Okay, so that's like the DDD dream, to make those boxes. But also, one of the reasons that why we're drawing those boxes and conceptualize it in your mind is to note that not all of those contexts deserve DDD-lite. Not all of those contexts are really super important also for us. So if you are wondering how to get from your legacy codebase to DDD, then you can save most of the time, possibly, by choosing which modules are really the most worth to be extracted from the monolith. And I think that's the most important skill here. So as I said, if we had this monolith here, I would probably start with extracting either finances or project management, because those are important to me. And the other ones, you can do it at some point, but it's probably not the first priority. So if we're talking about getting to DDD, it's all about priorities. So draw the context map, that's the beginning. Discuss it in your team. You need to have the common understanding of all of that. And decide which contexts are CRUD. CRUD is as in the meaning as the typical Rails way. And which ones need more logic. And by the way, the CRUDs will probably need to publish events anyway. So there will be like extended Rails way with publishing some events. It's worth noting that for big code bases, first of all, there's no chance that anyone will allow us to do a 2-month rewrite. It usually doesn't really make sense. We are adding new features at the same time. So it's an ongoing process. In some of our projects, it takes years, basically. So, and there is no such point of time that you can say, okay, we did it. So there is always something we can improve. Peopleware is the most potential risk in going from the legacy codebase to DDD, especially in the Rails community, where you have this split between people who strongly believe the Rails way being the best way everywhere and all the time, and if you want to switch to DDD, either DDD like the strategic thinking or the tactical, you may see a big misunderstanding. And we see many of the Rails people, the Rails way people, being like if they don't get the point of going to DDD, then they may cause problems at some point. So this may cause some kind of discussion or even conflicts. So that's the problem. I talked more about it in this blog post, so maybe you can look at it for more details. And the second part is when you are switching to DDD, the language, the vocabulary you're using is very important, because what we want to do with some parts of the code base, we want to make it closer to the business understanding. So we don't want, obviously, the business people to write the code, but at least we want to reflect the concepts from the business world in the code base as well. So the typical smell in our applications is that we use the words like create, get, update everywhere, while there is almost always a good domain-specific word for that. So maybe it's not a create new member, maybe it's a introduce new member to the team. Maybe it's not create customer, maybe we just contacted the customer, right? So there is always a good word that is more closer to what business people use. When you are going into DDD, obviously we are refactoring. And as I said, it's too risky to make rewrites. So you do it in small steps. And this is called refactoring. And if you are doing refactoring, you need to have a good test coverage. Otherwise, you are risking introducing regressions. What are regressions? Regression is a bug that appeared in a place where it previously has been working. And Uncle Bob has a nice example here. He's talking about going with your car because the brakes are broken, and you go to the mechanic and they are fixing it. So the next day you take your car and the brakes are fixed. But what you see is the back window is broken now. And this is totally unexpected, and this is like hilarious. But also this is what we do as programmers very often. So introducing regressions is really a huge problem. And over my career, I think my understanding of the damage that regressions are causing is increasing. I often talk to the customers and they love the speed of work, the everything, but you can have a really good speed of work for 6 months and then you do 2 regressions, so you break things that used to work, and suddenly you break all the trust that you have built. Because for customers it's very difficult, for non-technical people it's very difficult to understand how could this happen. Why is it that it was working? I ask you to fix point A, you fixed point A and you broke point Z. Why is that? So test coverage is one way of ensuring that you didn't break while you were changing something. Line coverage are the tools that are most often used, so like Arco for SimpleCov. They are useful in a way, but overall they are cheating you, and I even say that this is a joke. Mutation testing is an interesting concept where you can actually really rely on your test. And mutation testing, what it does, it takes your code, it builds an abstract syntax tree, the AST, it changes one part, like from false to true, or removes one call to a method, it runs your test, so it changes the AST, it's called a mutant, it runs your tests now, and it's expected that some tests will fail because you change the code base somehow. And if the tests don't fail, it means you have a mutant that stays alive. And that's a bad thing. It's a bad thing only when you are doing some kind of refactoring, because you can't really be confident about the changes. So I really recommend to go and try mutant. It will change your way of thinking about being safe during refactoring. And even if you don't stay with the tool itself, the mutant, it will teach you how to experiment with the code base to see how good is your test coverage. I know that in many situations you are sometimes in module A for 1 week and then you switch to module C. Very often you were not the original author of this code base. So for you it's important to understand how safe you are by changing the code base. So in a way, mutant is testing your tests, and then it leads to refactoring with more confidence. While we are at the topic of testing, in the Rails community, we are, I think, overly relying on mocking, and we are overly relying on testing single classes in isolation. And we treat almost every class as a unit. While sometimes units are classes, but sometimes units make sense as a collection of classes. So maybe you don't want to test the address class on its own. Maybe you want to test it with the user class or the customer class together. So try to find your units. Even I often consider, if you have those bounded contexts separated, then a bounded context may be a good unit. Some people will say that it's too high, that those boxes are too big to test, but I think that it gives you the nice black box testing, and you can change. So the idea is that from the testing point of view, it shouldn't matter if you do DDD-lite or you do CRUD under the hood. You can refactor from one to another without the need of changing the test. That's the idea. And here are some of the resources where I wrote more on this topic. So also what is very useful is that the framework itself brings you a lot of problems. And I'm not like criticizing everything about frameworks. I think Rails is very good for the HTTP part. So let's leave it. Let's use the controllers. Let's use the routes. But overall, I want to escape from the framework at the action level. So very, very soon. And so in the controller action, you want to probably call an application service, and that's a good place to start. Active record, meaning the pattern, not the library itself. The library itself is quite good. There are some bugs, but it's mostly okay. but the pattern of using the same object from the database layer to the view layer, this is something that is very not DDD-lite friendly, I would say. So in a way, when you're introducing layers, you want to then use different objects at different layers, and this may make you think that you are really creating a lot of new code, which is unnecessary, because previously with Active Record you didn't have this need. But if you're going to DDD, it will be very useful for you to actually get rid of the Active Record pattern, not the Active Record library, but the Active Record pattern of thinking. And if for any chance you use data mapper, then it's much more DDD friendly. So with Active Record, it's like a short-term loan. When we start a new Rails application, we are actually the most value we get is from the Active Record pattern, because we don't really need to write too much code, and we just take the database record and put it on the screen. And that's very quick speed. And I compare it to a short-term loan because it's similar to when we use the concept of technical debt. So we are taking the Active Record is something that either it brings you a lot of value. So as with short-term loans, you get some money very quickly. But then the longer you are paying the debt, the more you have to pay. So it's better to get rid of the Active Record pattern as soon as possible. And when we are on this topic, it's always good to ask the question, if we're taking this loan, are we able to pay the debt? What is my credit history? Like, did I ever get rid of Active Record before? So those are open questions, and I think it's worth thinking about them, because I've noticed many projects where people said, okay, we will just start with Active Record and Rails, because it's, in 2 days we will have a working application, but 3 years later it's still the same pattern everywhere. So, and 10 or 15 people are struggling with the decisions made in the first 2 or 3 months. This happens very often. So I'm not saying that never start with Active Record. It's just start, but then learn how to get rid of it evolutionary. Another problem with a typical Rails way approach, especially when you go to DDD, is that in the Rails way we have this params hash, which we get from the controller, and then it's passed into next layers almost without changes. And so this is, with DDD you will learn how to wrap it, how to give names to these params and hashes. Some people call it form objects, and like what is or DTO, and so you will learn how to actually unpack it in a useful way and to do the right thing at different layers. So in some situations you will decide that it's okay to have this, CRUD, Active Record codebase, but you may want to wrap it with a application services layer, and try to use from other places only call this new API. The reason for it is that with the Active Record way of working, we have those models, we have associations, and we have those dynamically created methods. And basically, and very often we are encouraged to just call the model whenever we want to do anything. But we have this almost infinite API. This is the term that I first heard from Markus Schirp, the creator of Mutant. So you have this infinite API, and I think that one way of being more disciplined with what you actually expose is building the API above it. But then again, it's only about your discipline if you really rely on just calling the high-level API and not calling the models directly. When you have those bounded contexts, you need to communicate between them. And we use events, and that's what DDD suggests. We built at Arkansas, we've built 2 gems. One is Rails Event Store, and the second one is Ruby Event Store. They're very simple things, and so they are building a table for events in your database, so you don't need to introduce a new database. And they give you some API for the object called Event Store, and you can subscribe for events, you can publish events, and you can retrieve those events. And the idea here is that if you start with a typical Rails application, you don't need to, maybe you don't even want to switch to several databases, but you want to publish those events, and introducing the events and the communication with events is much easier if you still live in the same database. So the release event store relies and actually it benefits from the fact that it's one database. It benefits from that because it's we assume that at the beginning of introducing DDD, it's better to be sync than async, so not change the previous behavior. And when you read the DDD materials or CQRS or even sourcing, they're very often related to async behavior. You read about concepts like eventual consistency, and this sounds really dangerous. It's not that dangerous as it sounds, but at the beginning it might not be a good idea to go this way, but just stay sync. So you stay sync thing means that you publish an event, another bounded context catches the event and handles it and does something, and it does it. So and you still do it all in one database transaction. So in a way, you don't change the behavior of your Rails application. And that's a good value for quite a while. So I'm suggesting not going async too early. And once you introduce those DDD concepts, you will sooner or later you will see the idea of separating reads and writes, which is both very simple but also very revolutionary. And this comes from the CQRS world. And you can see that some of your application services are basically writes, while other things are reads. You may want to introduce it at application service layer, but I've seen it also introduced at the domain services layer. I think both ways are worth trying. And so what it means that once you split reads and writes, you can use different objects for dealing with the writes, it's called commands, while different objects for dealing with reads, so for querying. And this is interesting how much it actually makes a difference here. When, for example, for reads, basically for reads you may want to stay with the typical active record way of thinking. So you just grab some data from the database, it's from active record, and put it on the screen, right? Render the view, and that's all, because reads are usually simple. While if you do the writes, the active record way of working might be too simplified. You might have bugs because you will see some problems due to the lack of layers. So for the writes part, you may want to use the idea of aggregates, repositories, and so on, while for the reads, maybe it's not needed. It's connected to the idea of read models, which we'll go to very soon. And also, what's very useful is to try not to query from one bounded context to another. So it's better to actually duplicate the data with all the consequences of duplicating, which are very risky. But if you manage to stay in sync, you can have those bounded contexts being like separate applications. So we can have commands and reads to the application, and it's like isolated place of code. You can even extract it to a gem. So push the data, publish the events, and let all the bounded contexts like persist whatever they need. Yes, and they are in sync because you're publishing all the events. So when you are creating a customer in one part of your application, so in the CRM probably, you're publishing an event called customer created or customer introduced, customer contacted, and in other places you persist the customer as well. But if in the CRM for whatever reason we are deleting the customer because we don't never want to contact them again, we may want to publish an event called like delete customer or don't customer set as don't contact us, whatever. And other places in the code need to handle it. So whenever you create, you also need to delete. When you have this split between bounded contexts, it's much easier to test, especially when you push the data and not query other systems, because it's much easier to test. You don't need to mock anything. You just call some commands or writes, and then you query, and you have like the consistent object or consistent facet for that. So read models are those things which are just for querying data. So they are also handling events. So let's say you have this CRM bounded context and you have the other finances bounded context. And what you want to do is you want to have a report which shows for each customer how much money we earned, for example. And you can introduce a read model which listens to event from the CRM, like customer created is one interesting event here, but also you are subscribing to events from the finances bounded context, like whatever like this amount was earned. So you persist those events here in the read models, and you are denormalizing the data, and you're creating the report while the write is happening. So it means in a way it's a cache, but it's a bit more than a cache. You can always rebuild it from the events. That's the interesting part. So this makes this is very often a good start to introducing DDD. In a way, read model is also a bounded context. You can think of it as a bounded context, and you can find some reports or some more complicated views, and you can build this read model. So you see, okay, I have this view, what kind of data this view relies on, and publish the events when this data is changed or created or deleted, and then subscribe in the read model and build this this data structure here. It's just a table in the database, so just build it when you write to those places, and usually it helps with the performance of building this report or building this read model, but also it makes your main code base smaller thanks to that. And it's quite safe. Introducing read models is quite safe in your application. You need the event store, you need the event bus, which sometimes is connected to each other, and then you need a new table in the database. You can do it with our gem called Rails Event Store. So, and I encourage to try it. Treat your frontend as a separate bounded context. It depends, obviously, what's your strategy to go with frontends, like whether it's JavaScript or it's just Rails views. But overall, the frontend can be treated as bounded context. Maybe they use some different vocabulary. You talk about widgets, clicks, handling UI events, and then they can publish the events and communicate. So you can publish with events even from a JavaScript frontend. You can publish some events, so send those events through the API to your Rails backend, and then you can handle those events on your backend. When you have an interesting problem to solve, like for example, if I want to introduce a rule that one developer is never assigned to more than 3 projects unless they are in maintenance mode. This is like a business rule. And if I want to ensure this business rule works, I may have like decisions to make. Okay, where is the logic actually fitting? So this is thinking in aggregates. So either this logic is put into the team aggregate, or whether it's a developer aggregate, or maybe it's a project aggregate, or maybe customer aggregate. So I'm not answering this question here, but it's useful to think in aggregates here. Once you have those events stored for most or all interesting situations in your application, first of all, you have a transaction log, an audit log, so you can see everything that was happening in your system from the beginning, almost. That's great, that's fantastic for debugging. But also you can introduce event sourcing, and it means that in the writes, so when we were talking about writing to the command part of DDD, you can actually build the aggregate not by restoring the last snapshot from the database, as we usually do. You can grab all the events related just to this aggregate and build this aggregate from those events. So you can imagine that it must be in the same state as this snapshot, right? And it's not like you are building from all the events that happen in the whole world. The events are always connected to an aggregate. So when we want to assign a new developer to a project, we want to build a project, and the project usually in the project management bounded context, they may have like, I don't know, 25 events, maybe 50 events. It's like not a problem to retrieve 25 events and apply them runtime in memory to an object, to an aggregate. So there's no performance problem here. Many people worry about it, but usually it's not a problem. I would like to warn that if you go to DDD and introduce the read models and publishing events, I would suggest to stay with one database for a while, because it might be tempting. DDD is very helpful to go microservices at some point. A bounded context is a very good candidate for a microservice, but then you are entering the world of the distributed world, and distributed transactions are tricky. So you need to educate yourself before you go this way. If you have a huge project, but it's split into bounded contexts, so small modules, smaller modules, and you are maintaining many projects because for historical reasons, You may note that it's much easier to bug fix when you have a much smaller thing to set up and run the test just for a small thing. Sometimes you may want to test this bounded context in integration with other bounded contexts, but sometimes you just know that you're fixing something internally. It doesn't really change the way it's publishing the events and so on. So you're not changing the public API, and that's enough to just set up one project, especially if your bounded contexts are gems. So at the end, I would like to recommend some books. I split them into two parts. So first, learn about DDD, and I recommend the Implementing DDD book by Von Vernon. It's really great. It's using Java code as an example, but overall it's really very useful, and like all the answers are there. There's this blue book, the classic book by Eric Evans, called Domain-Driven Design. It's a good book to read, but I suggest to start with the red book first. But so those are the DDDs. So this is where you want to get at some point. You want to also learn how to deal with refactoring, so the small steps in between. And couldn't recommend more the classical book by Martin Fowler called Refactoring. And also Michael Feathers talks. He's really showing many useful techniques for dealing with legacy code. And like, for example, sometimes you may want to build test coverage for just a small place called, you may want to introduce an object scheme and just cover it with tests, while in some other situations Michael Feathers suggests something different, so put more tests at higher levels. So the combination of all of those books will teach you how to do refactorings very well, but also it will teach you where do you want to go with this refactoring. So I've seen sometimes the teams that they refactor endlessly, but overall they're staying in one place. While DDD may show you one target. So it's one target point where you want to get. And the last position, this is obviously a disclaimer, this book was written by me, and it's like DDD-lite applied to the Rails world. So I'm showing how to refactor in small steps, how to introduce the layers. It's a good introduction to DDD-lite, I believe. But it's only focusing on DDD-lite. It doesn't talk about the bounded context there. So I hope you enjoyed this presentation. I hope you learned something about DDD. In case you have any questions, feel free to email me. And thanks for your attention. Goodbye.